Welcome to the DIY Honda Garage channel. This presentation covers the DTC P0102 MAF sensor circuit low voltage issue, specifically for the 2012 to 2017 Honda Accord. The mass airflow MAF sensor is crucial for measuring the amount of air entering the engine, which ensures precise fuel injection and optimal engine performance. When the MAF sensor malfunctions, it can cause significant drivability issues and trigger the P0102 diagnostic trouble code. This code indicates that the MAF sensor is sending a low voltage signal, potentially leading to incorrect calculations by the powertrain control module, PCM. Our troubleshooting will involve steps to diagnose and resolve issues related to the MAF sensor and its associated wiring. We will address possible causes, symptoms, and necessary repairs related to this DTC. The final troubleshooting step is designed to confirm whether the MAF sensor or the integrated air temperature IAT sensor is defective. To execute this, replace the faulty MAF sensor with a known good replacement and reconnect all related connectors securely. Following the installation, the ignition should be switched to the on-to position, and the next critical phase involves using the HDS to clear any existing DTCs. After clearing the DTC, start the engine and maintain it at around 2000 RPM without load for observation. This will help determine whether the P0102 code reappears, indicating an issue with the new sensor or other components. If DTC P0102 appears again, it would imply further evaluation of the PCM or other wiring issues would be necessary. The final repair verification step is vital for confirming that the repairs have resolved the underlying issue associated with DTC P0102. Start by ensuring all connectors related to the MAF sensor and PCM have been securely reconnected to avoid potential lapses in connection. Once confirmed, turn the ignition off and then back to the on setting position. Using the HDS, reset the PCM to clear any residual codes and to enable the PCM to relearn the optimal parameters for the engine's operation. Following this, perform an idle learn procedure to ensure the PCM can recalibrate its idle settings. Finally, monitor the system with the HDS to check for any pending or confirmed DTCs, making sure that the P0102 does not reappear. If the DTC is no longer present, this indicates that repairs were successful. Preventive maintenance is vital to maintain optimal performance of the MAF sensor and avoid triggering DTC P0102 in the future. First and foremost, schedule regular inspections of the MAF sensor, including cleaning and ensuring that it isn't obstructed by dirt or debris. A clean air filter is equally essential, as it limits the amount of contaminants reaching the sensor, helping to maintain accurate readings. Furthermore, periodically check electrical connections to ensure that there are no corrosion or loose wires that could impact the sensor's performance. Keeping the PCM with the latest software updates can enhance data interpretation and compatibility. Lastly, consistently monitor for air leaks in the intake system, as this can also affect sensor readings and overall engine performance, helping to prevent premature failures. In conclusion, the analysis of DTC P0102 highlights the crucial role of the MAF sensor in the efficient operation of the Honda Accord's engine. Low voltage signals from the MAF indicate possible malfunction that can drastically affect performance and fuel economy. To effectively address this, a systematic troubleshooting approach ensures that all potential causes are examined and repaired before further issues arise. Incorporating proactive maintenance, such as inspecting the sensor and wiring connections regularly and ensuring clean air intake can significantly extend the life of these components. Proper vigilance and timely repairs will not only enhance vehicle performance, but also increase confidence in reliability on the road. The DTC P0102 refers to a low-voltage condition occurring in the MAF sensor circuit, with the MAF sensor being integral to the vehicle's air intake system. This sensor is typically located in the air intake duct just after the air filter and before the throttle body, allowing it to accurately measure the airflow entering the engine. This data is sent to the PCM, which uses it to optimize fuel injection and maintain efficient engine performance. Additionally, the MAF sensor measures the temperature of the air as well, which aids in calculating the air density. Poor electrical connections or a faulty sensor can lead to a voltage reading of less than 0.1 volt, prompting the P0102 code. Thus, the health of the MAF sensor is paramount to the overall performance of the Honda Accord. Several factors can contribute to the occurrence of DTC P0102, starting with a potentially faulty MAF sensor itself, which can alter the voltage output. An open IG1 AFM wire can interrupt the power supply to the sensor, resulting in low voltage readings. Furthermore, a short circuit in the VGP line can lead to incorrect readings, whereas an open VGP line will prevent the circuit from transmitting any signal. It's also possible for the PCM software to be outdated or malfunctioning, which may affect sensor interpretation and output. Each of these issues must be considered and tested systematically during the troubleshooting process to ensure accurate diagnosis and repair. When encountering DTC P0102, the driver may notice various symptoms that directly affect vehicle performance. Commonly reported issues include engine performance glitches, where the vehicle may struggle to accelerate smoothly or exhibit loss of power at certain speeds. Fuel economy may also decrease due to incorrect air-fuel mixture ratios resulting from the low voltage readings from the MAF sensor. Additionally, drivers might experience a rough idle condition where the engine runs unevenly at rest or even stalling during acceleration if the ECU cannot adjust fuel delivery accurately. Lastly, the illuminated check engine light serves as an immediate alert, indicating that the onboard diagnostics have detected an issue related to the MAF sensor circuit. The first troubleshooting step for DTC P0102 involves turning the ignition switch to the on position or pressing the engine start button to enter the on mode. It's essential to wait for approximately 2 seconds after doing this. Using the Honda Diagnostic System, HDS, one should check the voltage output of the MAF sensor. The measurement should register less than 0.1 volts if the sensor is malfunctioning, confirming the expected conditions, marking the presence of the error code. If the current condition matches the threshold, it indicates a failure that's been duplicated, necessitating further testing. However, if the conditions do not align, it could be an intermittent issue, requiring checks for poor connections or loose terminals at the MAF, IAT sensor, and the PCM before proceeding. In the second troubleshooting step, begin by turning the ignition switch off. The next action is to disconnect the MAF sensor IAT sensor 5P connector to isolate the MAF sensor from the circuit. Once disconnected, turn the ignition back to the on position to prepare for voltage measurement. Using a multimeter, measure the voltage between the designated test points with the connector still disconnected. Specifically, measure between the MAF sensor connector number 1, which is usually the black-yellow wire, and the body ground. An expected voltage reading equivalent to battery voltage indicates the integrity of the IG1 AFM wire circuit. If voltage is absent, it points to an open circuit that needs repair. For the third step in troubleshooting DTC P0102, first, ensure the ignition is turned off. This step involves measuring the resistance between two specified points to check for continuity in the VGP line. With the MAF sensor IAT 5P connector still disconnected, from the harness, calculate the resistance between test point number 3 of the MAF IAT connector and body ground. The expected resistance range should fall within 190 to 210 kiloohms. If the resistance falls within this range, it indicates that the circuitry is intact and functioning correctly, prompting the technician to proceed to the next step. Conversely, if there is no continuity, further exploration is necessary to identify the faulty components in the circuit. In this step, the technician must jump the SCS line using the HDS tool, which allows for troubleshooting without entering the SCS mode inadvertently. After ensuring the SCS line is jumped, the next critical action is to disconnect the PCM connector B, which contains multiple wiring terminals. With both the MAF sensor IAT connector and the PCM connector disconnected, continuity needs to be checked between the designated test points related to the VGP line. If continuity exists, it indicates that there is a short somewhere in the VGP wire between the sensor and the PCM. If a shorted condition is found, repair the wiring accordingly, as this could be contributing to the low voltage output seen in the MAF sensor circuit. The fifth step in troubleshooting involves yet another continuity check between the test points, keeping both the MAF IAT sensor 5P connector and the PCM-B connector disconnected. This test will confirm whether there is an open circuit in the VGP line, which would prevent the MAF sensor from operating correctly. If continuity is confirmed between the two test points, this indicates the VGP wire is intact and functioning properly. If there's no continuity, it confirms an open circuit that needs immediate attention. The repair would involve diagnosing and fixing the breaks or faults in the wire between the MAF sensor and the PCM to resolve the low voltage signal output. Please like and subscribe to the channel. See you next time.